Atoms are the building blocks of everything. The ground you walk on, the air you breathe, and the water you swim in. In this video, we'll be talking about atoms, elements, molecules, compounds, and atomic models. We hope you enjoy it and learn something new. Atoms make up everything we see and everything we feel. Now, the basic structure of an atom consists of a positive nucleus surrounded by a shell of electrons. This is a helium atom. It consists of 2 protons and 2 neutrons in its nucleus, surrounded by a shell consisting of 2 electrons. But we'll be going deeper into this later in the video. So, when atoms chemically bond together, we create molecules. This is a hydrogen molecule consisting of 2 hydrogen atoms chemically bonded together. This is a chlorine molecule. This is a molecule of oxygen and a molecule of nitrogen. So when different types of atoms chemically bond together, we create compounds. The most commonly used compound is water, consisting of an oxygen atom chemically bonded to 2 hydrogen atoms. This is carbon dioxide, consisting of 1 carbon atom chemically bonded to 2 oxygen atoms. And this is methane, which you may be familiar with if you have gas stoves at home, which consists of a carbon atom chemically bonded to 4 hydrogen atoms. So in science, a mixture is a material made up of 2 or more different chemical substances which are not chemically bonded. Now, the most common mixture that everyone knows is air. The air is made up of nitrogen, oxygen, and also has other gases such as carbon dioxide, neon, and hydrogen. Another example of a mixture could be salt water, something that you would find in the sea. And now I'll be passing on to Courtney to talk to you a bit more about atomic models.
Thank you, Zed. Now, the concept of an atom was first coined around 400 BC by ancient Greek philosophers, but the concept was modernised around 1800 by John Dalton. He created this model. It's just a sphere. It's an indivisible sphere. Not made up of anything, but makes up everything. Now, later on you get to around 1900, early 1900s, you get the plum pudding model, which was basically a sea of positive charge with negatively charged particles within it, eventually became known as electrons. Afterwards, slightly afterwards, you get this model, which is a positive charge there, positive nucleus, as you can see in red, surrounded by electrons. But after that, you get to Bohr's model. Bohr's model takes the electrons to be within certain orbits or certain shells, as opposed to the free-flowing electrons in the previous models. Now you get the nucleus. This is a neon atom. You get the nucleus, you got 2, and you got 8 around the side. Now this is Schrödinger's model. Schrödinger was big on quantum physics. This is more of a A-level model with orbitals, which are basically areas of probability where you're most likely to find an electron at any given point. Again, this is quantum physics and A-level. If you choose to take A-level chemistry, you'll definitely encounter that. But back to Bohr's model, which is particularly useful. It takes the nucleus and then the shells, and on the first shell you can fit 2 electrons, and the next you can fit 8. This is oxygen, so there's 2 there and 6 because there's a total of 8 electrons. Now for sodium, you've got 2, 8, and 1 on the third shell, account for 11 electrons. Some versions of Bohr's model will have electrons paired up, particularly in the second and third shells, but some don't, as you can see here. Anyway, back to you, Zed.
Thanks, Courtney. Now I have some fun facts about atoms. In a grain of sand, there are 50 billion atoms. And if 7 billion people, so the population of the Earth, were the size of an atom, we'd still only take up 1 millimeter of space. So why can't you trust atoms? It's because they make up everything. And on that note, guys, thanks for watching and stay sciencey.